Hello everyone, my name is Mark Schonagle, Senior Developer Advocate here at Unity Technologies, and without any further ado, I'd like to premiere for you the latest real-time cinematic trailer created by the award-winning Unity demo team based in Stockholm, Sweden. This trailer is 2 minutes long, and afterwards I'll show you some of the exciting technology that was used to create it. So sit back and enjoy Enemies.
I have in my head everything that anyone has ever known. You have in your heart everything anyone has ever felt. Power is given only to those who dare to lower themselves and pick it up.
Wow. Just wow. What else to say? That's all real time, rendered at 4K, absolutely gorgeous. Geez, I really love working with the Stockholm team. They're the ones that did Book of the Dead, Adam, The Heretic, and a bunch of other short films here at Unity. It's always groundbreaking stuff, and obviously this one's no exception. So anyway, here we are in the Unity editor, and today I'm going to talk to you about some of the new eye technology that was developed for Enemies, the new skin tension solver, our new real-time hair system, and even look at some fun NVIDIA-specific stuff like DLSS. So before I do that, I just want to show you a couple slides to explain how we actually scanned this actress's head, got her into Unity, and then we'll dive into the editor for the rest of the demo. Reproducing facial movement with all its subtleties. What does that even mean? Well, basically, how do we make a realistic digital human? We look at people all day, every day, so we notice right away when something isn't right. The uncanny valley, it's called. So it's a big challenge. The research started here at Unity with Gawain from The Heretic, where we scanned a real-world actor, and we did a similar process for Enemies, only developing some new techniques to further improve the look. Essentially, there are three main steps to the process: data acquisition, the scan; data processing, cleaning it up; and then into Unity for the rendering tech. The first one, data acquisition, is done like this. Meet Louise. She's the actress that we hired to be volumetrically captured and forever immortalized in the Enemies demo. Second, data processing. Cleaning up the data, stabilization, alignment, everything really to make the mesh usable in 3D. Now there are tools for this available for you to do yourself, or service providers out there that can do it for you. And lastly, bringing it all into Unity for the addition of things like wrinkle maps, hair, lighting, etc. So that's it for slides. Let's jump into the editor and we'll start to take a look at how we made those amazing eyes. All right, so let's get started. One thing we can say for sure is that we have some beautiful eye technology going on inside Enemies. This project is using the High Definition Render Pipeline, or HDRP, and a modified version of the included HDRP eye shader. As I scroll down my inspector, you can see a number of parameters that we can adjust to control the various attributes for the rendering and for the animation of our eyes. Now this frame's a little bit dark, so I'm going to move to frame 2500 on my timeline. And I'm just going to go switch to my scene view, where I can just orbit the camera around freely and just take a look at this thing from any angle and just marvel at it. Look how beautiful that is. I'll go ahead and unselect it to get rid of that manipulator, and check that out. So I mentioned we were using a modified version of the HDRP stock eye shader. What does that mean? Well, if I go here to my assets folder and I create a new material asset, I can then go into the shader settings and switch from the default lit shader to the included eye shader. But if I scroll down, I can see we're missing a bunch of the parameters that we saw in the other shader. So what's going on there? Well, to answer that, let me first pull up the documentation page for the included eye shader. It's actually quite an impressive document. A bit of anatomy, a ton of knowledge on texture maps, shading methods, workflows. And if we scroll all the way down to the bottom, we can see the parameters that are exposed on the inspector inside Unity. Well, what about all those parameters that are missing? Well, that's where the demo team comes in. If I switch over to their Digital Human GitHub page, I can find a collection of tools that they used for the creation of their last short film, The Heretic. One of the great things the team does is give back to the community, knowledge and tools that they have created making cinematics. Things like this eye shader, tools for importing 4D capture data, or the skin attachment system. All sorts of tools like this just get released back to the community for you to enjoy. So that's where this eye shader comes in. They took the already enhanced shader from The Heretic and added even more features. And that's what I'm going to show you now. Now basically, the human eye has a cornea, which is a lens that sits on top of the iris that bends or refracts light. Now the stock eye doesn't have the ability to do that refraction, so technically it's incorrect. Now for The Heretic, the demo team extended the eye shader so that it would refract light, which as a result generates energy inside the eye, but unfortunately that energy at times makes the iris very uniformly lit, like we see here. Finally on the left is the new and improved eye shader developed for enemies, which adds caustics. Caustics, if you didn't know, is what you see at a swimming pool when the waves create light rays that seem to dance around the wall in the bottom of the pool. That same effect happens in your eye, which is now replicated in the new eye shader. So now that we know a little bit about the shader, let's go ahead and tune some of the parameters back inside of Unity. So what I'll do here first is just select the eyeball, and you can see it puts this little orange ring around it. Now if I orbit around a little bit, you can see that the eye actually has a bump to it. It actually has a bulge there, and that's going to allow us to get those perfect refractions that we were talking about. So let's kind of position this here, and I'll pin my inspector so that I can then turn off the eye and we can just focus on the eyeball. Maybe zoom in just a bit. And so now if we scroll down the inspector view, we'll stop here at the eye renderer script, and you can see all of the different parameters that we have to control the eye. The first one I'll start here is the texture roll for the sclera, and you can kind of see what's going on there. Let me rotate the camera a bit. And really what this is doing is just rotating the albedo texture map and the bump for the sclera texture there. So if we go down here to the material shader, I can start to show you some of the different texture maps that are driving this. Here we see the albedo for the sclera. Here's the albedo for the iris. And then here we have the height map for the sclera, which gives us the roughness. And the same thing for the iris. All right, so let's go back up to the top here and start to look at some of the other parameters. I'll show you that roll again, now that we know what's driving it. There's the cornea down here. The cornea has some neat little controls. So first I'll just adjust the index of refraction, the IOR, and we can see how the light is refracting on the cornea. So I'll just spin this back around, show it to you from a little different angle again. You can see it's quite dramatic. It really distorts the light quite a bit. Below that we have the iris's IOR, and you can see it too is very dramatic as it kind of almost pushes and bends the light. Below that we have the smoothness, which is how it renders the specular, whether it's a soft diffuse specular or a very hard rigid specular like we see there. And again, if I just rotate this from a different angle, you'll see the bump map working on it. Now again, this is only on the cornea, so yeah, you can just see it just till it gets to the ring there. Cool. All right, so I'll orbit around a little bit. We can see this from a couple different angles. And next is subsurface scattering. So you can see this makes the iris nice and sharp, or smooths it out or flattens out a little bit. This is how light moves through translucent objects, which is kind of neat that the eye supports that. The limbo ring power is next, and you can see that puts a ring around the iris. I kind of made it obviously a little bit big there just so you can see it. We can also go and change the material color for it. So we'll go down back to our material properties, and maybe I'll make it orange. Orange would be bad. You'd probably want to see a doctor if you had a orange ring, but anyway, we'll make that back to gray, a little bit neutral, and then again, just reduce the scale. So under that, we have whether or not the iris is actually refracting light, and you can see that on or off. It's very dramatic. And then the pupil size, or a lot of pupil options, but here's the adjustment for the pupil size. If we're going very small or crazy big, anything in between, these can obviously all be animated. So a lot of neat little controls in here, a lot of other controls for the pupil as well. So below that, we have some occlusion options for doing things like occlusion from the eyelids onto the eyeballs. That is the ASG, or anisotropic spherical Gaussian setting that we see here. Say that one 10 times fast, as well as some other occlusion parameters below that one. All right, so moving on down the line. At the bottom here, we have some of our caustic features. So here's the caustic cornea radius, and this is where I can start to show you some of that cool caustic effect. So these numbers are very precise. So if you change the value to a lesser number, we see less power, less energy. Kind of orbit around a little bit. That's just so cool looking, really beautiful. You make a couple more changes here. Just kind of bump the power down, bump it up, and again, you can really see that effect going on in there. So let's see what else we have. Below that, we have the caustic intensity, which is a multiplier, which allows you to easily just scale the intensity up or down. And then lastly is the blending, which went a little extreme in that side, but just kind of how the caustic blends upon the iris. And that's it. That is a tour of the new HDRP eye shader found inside the new Cinematic Enemies. One of the challenges the demo team had to overcome with their latest creation was having realistic human-looking hair that could perform in real time. Not having a viable solution, they decided to write their own. So I'll press play here, and you can start to see as we get closer to her that she indeed has a beautiful head of hair on her. It's flowing, has these really nice styled grooms, it renders beautifully, and has built-in physics so it animates just like hair should. Now there are so many different types and styles of hair. You can see there are a ton of options here for you to achieve really just about anything. Long, straight, curly, short. Towards the bottom here we have a couple sliders that are animating. That's going to control the gravity here. You'll see her hair kind of rise. As this effect happens, the chest pieces rise, everything drops including her hair, and it comes back to its really nice, beautiful resting state. All right, so let's back the timeline up a little bit and just kind of get a wider shot. I don't have time to show you nearly any of the parameters in here, but let's just take a look at a few of them. Obviously, we've seen gravity. And what's cool about gravity is you can see it retains the original shape of the grooms that are in the hair. So you actually have like little clusters in there, which is different than stiffness, which is almost more like hairspray. We kind of think about it where it loses the initial kind of memory of what the hair was like. There's substeps here, which increases basically the number of curves in there. You know, and again, we can go into all sorts of different parameters. There's a whole bunch of parameters that we're not even on the screen right now. So if we go into the materials here, we can change obviously the color. The smoothness is going to give us more of I can see they're more like a high contrast hair. And if we take the smoothness off, this will kind of dull the sheen. Maybe she didn't use enough conditioner that day. But, you know, all sorts of different parameters for rendering, as well as the control of the actual shape. Here, I'll change some color just to show you a little bit of that. You know, obviously really simple to do that. And yeah, let's just go back kind of something to what we had. That looks pretty good. So let's talk a little bit about some different grooms or different styles. So I'll go ahead and just turn this one off or deactivate it in the inspector and select this other one and activate that. And you can see it immediately inherits the physics. It's, you know, as soon as you basically add these to your enable, then they inherit the physics, they inherit the rendering. And I could go and show that by just adjusting the stiffness here, and you can see that reacting appropriately. We're getting a lot of nice collision detection. If you were to spin her head around, it's fairly slow moving in this scene, but it behaves accordingly. So I'll go back to the other one. Just want to show you another nifty little thing here. If I rotate the camera, we can see that the hair actually flows right behind her ear, the way a lot of women wear it. Very cool. And that actually sticks, so you can rotate her head, and sometimes a few strands or clumps will fall over that. Well, how do we actually get these different hairstyles? Where do they come from? Well, rather than reinvent the wheel again, we chose to work with existing technologies that already do hair grooms. Here we're looking at XGen and Maya, we support Houdini, and Weta Digital's Barbershop, which Unity recently acquired, all of which allow you to make all sorts of custom grooms. All right, so we are back in XGen, just going to show you a couple variations. So I'll hide this one, and here you can see a little shorter style. This next one's really fun, especially inside of Unity, to see all those tight curls bouncing. They really preserve that shape. Now we're back to just showing you some different styling techniques. Don't want to focus too much on this, but this is essentially how you create the different clumps, how you create the different strands, get that hairstyle exactly the way you want it, and import it into Unity. And lastly, just want to show you that we can do all kinds of other stuff with hair. So here we're using it for eyebrows, eyelashes, even the peach fuzz on her face. It's all simulated, all rendered with the new hair tools. And these are all going to be inside the Digital Human Kit, so you'll be getting these tools as well very, very soon, so you can have fun yourself. One of the really cool new technologies found in this demo is the new skin tension solver. And what that allows us to do is blend between several different texture maps depending on where the skin is stretching and squishing. Now if I go here to my rendering debug mode and set it to normal map, I can see the directional normals that are on her face and body. Let's just zoom in here. We can see on her lips we have a lot of wrinkle detail going on. If I open up the material shader for this, we can see we have this new tension controller UI. So if I double click here, this brings up the normal map. This is the unwrinkled version here and the wrinkled version here. And based on the tension of the skin, we're able to blend between the two normal maps. So for instance, if I move to frame 1450 on my timeline and step forward a few frames, we have a different amount of wrinkling based on the tension or compression on her skin. Now what's really cool is if I turn on the rendering debug mode and turn on the show tension checkbox, this coloring is what is actually driving the blend. This is changing and calculating every frame based on whether her skin is compressing or stretching. And it's happening to the entire face. Now this will work on any model. It doesn't matter if the face was animated with a rig, a 3D volumetric capture like we have here, it just works. Another thing I can change is the scale of the effect, so we can have more or less exaggerated blending like we see here. If I turn the render debug mode back to normals and zoom in here, as I change the tension scale value, you can see on her lips where the wrinkles come and go. Up here in her upper lip, you'll see a nice exaggerated example as well. So just another way for you to add more realism to your digital humans. The last thing I'll point out is this shader is entirely created with Unity's powerful shader graph tool. So if I go up here and edit the shader, it brings up the shader graph, which is calculating the entire effect and also doing the blend, so no coding was required. Again, this tension shader tool will be released soon as part of the Digital Human Toolkit. So now let's talk a little bit about ray traced rendering. The enemy cinematic is rendered in one complete pass. That is, there's no compositing or any additional effects. It is output straight from the Unity engine using the High Definition Render Pipeline, or HDRP. Even cooler is that the final executable is rendered at 4K, fully ray traced using an NVIDIA RTX powered GPU with DLSS enabled. All of the materials, reflections, shadows are all physically accurate, like the ones we see on the desk and on the effect going on behind our protagonist. The entire scene was assembled using Unity's timeline feature, so we can easily scrub and navigate this entire cinematic. Over in our project settings under HDRP, we find a checkbox that enables ray tracing. And there it is, real-time ray tracing enabled. Cool. All right, so I'm going to go ahead and just reset my viewport here really quick. And I'm going to go ahead and turn off our hero character. We don't need her in the scene for now because I want to focus on the background. And if I just go ahead and select the material shader for that moirate effect, you can see that when I scrub the timeline, it's fully animated. You can see it kind of reveals planet Earth behind there as that center becomes transparent. So if we scroll down on our shader, we can see I've got several different texture maps and also a color widget. So I can change the color here, make it a little bit pink, make it orange, whatever. And look at just how all the reflections, everything just updates right in the scene, right in the viewport, all fully ray traced. Just amazing what you can do with these GPUs these days. So anyway, we could make this, way oversaturated if we wanted to, which just is, that's probably way too much. Ooh, that's definitely too much. Oof, kind of back that off a bit. Or maybe just undo all that and close it up and continue with what we were doing. So I'm going to go ahead and swap my game view here and just make it so that I have two viewports so I can kind of have that one camera right on the desk so you can get a better idea of some of the changes that are happening and just see some of the fun of ray tracing. So yeah, so let's just go ahead and position this camera. And again, seeing the reflections on the table there. Now we're using some different texture maps to drive that actual effect, so how the window is coming transparent. So I have some different kind of noise effects. And if you look at the window, see how it kind of changes? Now we have those little angular shapes in there, right up in there. That's all being driven just by that texture map. If I look at this, you can see it's clearly the same pattern that we see on the window. This one's a bit noisier. Here again, very similar, almost too similar. Maybe we'll try one more. This one's sort of subtle, Very similar to the one that we started with. Actually, let me try one more. This one here has some little dark spots on it, which is kind of neat, adds a little bit of variance to it. Now, this whole overall effect was supposed to be like a jumbotron or like an LCD screen, the way you get those interesting patterns in there. So what we did is we actually used a pixel image just like this, and just to show you a couple variations, you can see how much different it changes just by changing that pixel texture. Part of the reason for that is there is a multiplier to it, so I can make them get really small or really big, like that. Very neat. And then again, just trying some different pixel combinations. This one has a bit more black around it, so we'll have more of those edges visible. But yeah, it's all ray traced, all fun. Here I can add some noise. This is pretty cool. The noise can be animated. And you'll notice in the scene view that it's animating in the viewport, but in the game view, it's not. It only animates in the game view when I scrub the timeline, which is what you'd want. So it's a controlled effect, but you can at least get an idea what it's going to look like as a preview. And the reason for that is a little trick you may not know of, which is the always refresh toggle in the scene view. All right, cool. So I want to show you one more thing as far as rendering goes, and that lives on the main camera. So I'll select my camera, and this actually ships with Unity, so you don't have any packages to include. Let me just expand my viewport here a bit. And if I scroll down about halfway under rendering, we see allow dynamic resolution. So I'll check that, and then allow DLSS. And what that does is it activates NVIDIA's proprietary deep learning supersample algorithm, which is an AI, which I have no idea how it works. We kind of call it voodoo magic around the office. You just simply set a performance setting, a couple other parameters you can set under custom if you want. But essentially what it does is it uses an AI to up-res your scenes. And it's incredible. It's magic. Here on the left, I've split the screen halfway. We're running at 23 frames a second, 4K DX12 native. Here on the right, we're using DLSS. And look, we've got almost twice the frame rate just by checking a checkbox. It's absolutely incredible. Encourage you to use it. We love it here. And yeah, just magically works. So thank you, NVIDIA. And that, my friends, will conclude this presentation. I hope you enjoyed it, and I hope you learned something. Thank you.